Last month, there was a dramatic display of technological advancement and national pride. South Korea and the United States fought each other to get the crown of the first country to launch 5G mobile service. Both preponed their launches to gain the crown and ended up by launching 5G service within few hours. But this fierce competition was because of the hype 5G has created by promising up to 100 times faster internet speed and very fast response rate compared to 4G network. For example, it may revolutionize the way surgeries are done, where a doctor in New York can do a surgery in Los Angeles using a robot. 5G may also be key for autonomous vehicle technology to truly take off. Gaming, virtual reality, and drones are some other technologies that are betting big in 5G. But when 5G was actually launched last month, the early users in both cities faced many problems. Nikkei Asian Review reported that in South Korea, they were able to see a maximum download speed of close to 500 megabits per second, which is close to 10 times faster than 4G. The Verge website reported a similar speed of 400 to 600 megabits per second in Chicago. But in both places, the 5G coverage vanished within hundreds of feet and constantly dropped to 4G network. Nikkei also reported that the 5G coverage was poor indoor and in underground metro stations. So, after years of excitement, what caused this disappointing start? Hi viewers, in this part of the series about microwave frequency band, we are going to answer this question by understanding how 5G communication works. Before we proceed, I would strongly recommend you to check out our previous video about how mobile frequencies are selected if you have not done it, as we will be referring to some of the concepts from that video. Without any further delay, let's get started. First, some basics about 5G. The fifth generation of mobile communication is characterized by three things. First, it offers very high-speed data transfer or high bandwidth. This is because of the higher frequency spectrum being used by 5G. Second is low latency, which means faster response. For example, when someone clicks a link, the response from the website will be 20 times faster in 5G compared to 4G. The third is the network will be much more intelligent and can also handle more devices. That is, depending on if you are a cell phone or an ATM machine, the 5G will work differently. For ATM machine, which needs network connection only when being used, 5G will make it more efficient and connect it with low bandwidth network. On the other hand, a cell phone may be connected with a higher bandwidth network because of the way cell phone works. But what are the frequencies that are used by 5G? According to the Telecom Regulator Authority of India's analysis publication, the frequencies that are considered for 5G worldwide network are shown here. We can see that the frequency range is much higher compared to 2G, 3G or 4G. Recollecting from the last video, the highest frequency of 4G was 2.5 GHz. But we can see here that 5G may use a frequency as high as 70 GHz. Such higher frequencies will be key for 5G technology to achieve the promised speed of up to 100 times faster internet compared to 4G. But such high frequency bands are also the reason behind the poor experience the early users had in Chicago and South Korea. As we saw in the previous video, the coverage provided by a cell phone tower decreased drastically for a 2.5 GHz signal compared to over 5 miles of coverage for a 700 MHz signal. So, when the American company Verizon used 28 GHz frequency to provide 5G, its coverage was less than 100 feet. This is because these higher frequency spectrum, also known as millimeter wave, can only offer good communication when there is no object between the transmitting tower and the receiving device. But we all know that in real world this can never always work. To overcome this, Verizon and other companies are using what is known as beamforming. In simple terms, if the transmitting and receiving device have some object in between them, the 5G transmitting cell phone tower will send the signal in different direction so that it is reflected and then reaches the receiver, as we can see in this simple animation. This is simpler to say, but in real world scenario, it is extremely challenging to do so. And as we can see from the early users, these techniques have a long way to go before they are reliable. This is also the reason why 5G is intended to work in two frequency ranges. The lower frequency range, known as sub-6, are the frequencies less than 6 GHz, and the other is millimeter wave frequency, which we saw earlier. Based on the early user experience, the sub-6 frequency will continue to be popular till the time the problem with the millimeter wave frequency are sorted out. Alright viewers, we will pause here. In the next video, we will see the different strategies used by American companies to deploy 5G network.